First up is going to be Bill Paterson talking about HERMES, which is on the gateway. And I think this is going to be one of a really exciting talk because it's one of the first instruments that's going to the moon for Artemis. And so, Bill, please take it away. Just as a reminder to speakers, I will be interrupting you at about 2 minutes to give you a warning, and then probably again at 30 seconds or so. And if you start going too far over, I don't know, I'll do something weird. So please, try to keep to time. So thanks, Bill. If you want to get going, that'd be great.
Yeah. Oh, good. Because I lost my WebEx screen and the host has just unmuted me. So let me
Awesome.
get started here. Um,
And I see it going into full screen mode, I think. Yep,
yeah,
there we go.
yeah, hopefully. Okay, very good. So this is a title slide, obviously. I'm Bill Patterson. Been working for the past couple of years as a project scientist for this Hermes project. And let me acknowledge my co-authors. These are for the most part, these are the PIs and their deputies for the instrumentation that is part of Hermes. And then I've also included the last two authors on here are actually responsible for setting up our science data center, which I think hopefully is going to matter to people. But I'll get to that. So Hermes is an acronym, of course. It's the Heliophysics Environmental and Radiation Measurement Experiment Suite. Sort of a mouthful, not as contrived as some acronyms. Happy to say, it actually makes a bit of sense. So I think it's a pretty good one. So this, in fact, is sort of a summary slide for this presentation, and I think in this case it makes sense to put the summary up front and sort of read through some of the facts of the mission that people might not be aware of. It's also, if I do it first, there's no risk that I will run out of time before I get here. But Hermes is a package of instrumentation, space weather instrumentation or heliophysics instrumentation that will be flying on the Gateway, and in fact, it launches with the first two Gateway modules. It's an SMD mission, a heliophysics mission. Four in situ instruments. These are meant to measure the charged particle environment, both at the low energies and at higher energies, and to tie those observations together and understand the interplanetary medium and the terrestrial magnetotail. Of course, we take a magnetometer along to measure the magnetic fields. Uh, Launch of the Gateway is now, we're expecting November 2024. Certainly not earlier than November 2024 is the gateway line on this. And because we're traveling out to the moon with a low thrust ion drive, it's actually going to take quite a while to spiral out there. It'll be about a 1 year transit to lunar orbit. And once we reach lunar orbit, we start our 2 year nominal science mission there. The uh, Actually, there's something quite fortunate about this. Not under our control necessarily, but with 1 year transit and launch November 2024, we will arrive in lunar orbit probably just shortly after solar max for solar cycle 25. And since we're interested in part in solar activity, this turns out to be quite useful. The science here leverages a couple of things. I should say the instrumentation is heritage instrumentation. This was a directed mission because the opportunity came up with not much time to get it together. So it was directed to Goddard. The instruments were chosen because of their high heritage, and so there are on other missions instrumentation that is similar in its capabilities. That actually turns out to be quite useful because, in fact, Gateway will be in this unique polar orbit, and having other heliophysics assets at other locations allows us to conduct some studies that will investigate things like structure. I'll come to it in a minute here, but we'll be looking at some fundamental topics in heliophysics. There's a couple of things to be read between the lines in this bullet. One of these is that we are not necessarily directly conducting any kind of lunar science, although I'm certain that the measurements that we'll be providing are quite suitable for some investigations of the lunar surface and the lunar exosphere and the interaction with the exterior medium. And hopefully people will find a way to use the measurements to do that. The other thing is that this is, again, fundamental heliophysical science. We are not conducting operational space weather. Our connection to operational space weather, though, is that we see this as a pathfinder for future space exploration payloads. Our belief is that for lunar exploration we have good assets at L1 to measure the in situ environment approaching the moon, but in the future, if there are missions with crew conducting deep space exploration and they are well off the sun-Earth line, it's probably going to be pretty prudent to take along some sort of space weather monitoring system, partly for the purpose of providing alerts, but maybe more importantly is that local measurements are going to be needed to help make predictions that are relevant and accurate at the location of wherever that spacecraft and that crew happens to be. For HERMES, the science objectives will be addressed by our instrument teams, but this is in collaboration with 6 external science teams. These are interdisciplinary science teams that were selected during the past year or so. In fact, 2 of the PIs for those teams will be following me in this session. And in addition to this, I need to mention that we have some really significant international participation that is still developing, but certainly with Canadian Space Agency and European Space Agency and Japan Exploration Agency. And in fact, they will be flying a couple of companion payloads on this first launch of Gateway module. So let me get to this important detail. The background figure shows the initial Gateway modules. The one in the back that is sort of shaped like a shoebox is the power and propulsion element, and the one in the front, which is more cylindrical, is the habitation and logistics outpost. And in fact, that's where HERMES will ride. It will ride near the back end of the habitation and logistics outpost, the halo. You can't see it in this figure because in fact, Gateway did us the favor of moving it to the side you can't see here, because that provides us with much better viewing of the Parker Spiral and also the solar wind. Initially, we were on this near side, and that was not particularly suitable for our purposes. And then the inset here shows you, of course, the Earth and the Moon and the orbit plane, and then the orbit of the Gateway itself, which is it's not a Keplerian orbit; it's a halo orbit. It has a 7-day period, so it goes around the Moon 4 times during one revolution of the Moon about the Earth. It's pretty eccentric, 3,000 kilometer periapsis over the North Pole of the Moon and 70,000 kilometers beneath the South Pole. Although there are other assets already in orbit at the Moon, that's a unique feature that we make use of during this mission. Let me tell you a little bit about our science goals and objectives here. We have actually 3 different three separate goals, which we've designated A, B, and C. Uh, Goals A are related to the interplanetary medium, transport of mass and energy in the solar wind. Goal B, because we spend approximately 1 week out of 4 in the magnetotail, as does the moon, is to characterize energy topology and ion composition in the deep magnetotail. And so if you were to peruse these objectives over here, you would find that a lot of this has to do with examination of structures there. I'll come back to that in a minute. Our goal C is rather different. Although these are heritage instruments, science teams have a lot of experience with working with measurements from the particle spectrometers, the energetic particle telescope, the magnetometer. Typically, these instruments ride on spacecraft that were designed for the purpose. They're magnetically clean. They're frequently spinners to provide full view of the sky for the particle instrumentation, and other factors here. That is far from the case with Gateway. Gateway is designed for exploration and for human habitation and as a docking port for other vehicles. And we expect that the observational conditions are going to be non-ideal. So with regard to future exploration, if this is going to be necessary to carry space weather stations in the future on vehicles with crew, this is a good opportunity for us to learn how to do this. And so we will be working with, for example, European colleagues and the Moon to Mars office to develop this capability. And I think it's going to be a significant challenge just to fully understand the measurements, but I also think that these teams are going to get there. So I think I sort of mentioned already, to get scientific gain out of this mission, we really leverage 3 factors that are sort of equally weighted or dependent on one another. One is this polar lunar orbit, takes us out of the equatorial plane. Second is that we have instrumentation in common with other heliophysics system observatory HSO missions. So this will allow us to compare measurements to investigate structure. For example, for larger scale structures, there's spacecraft at L1. For somewhat quite a bit smaller structures that we can compare with, for example, MMS. For fine structure, quite conveniently, we have a couple of Themis Artemis spacecraft in equatorial orbit at the moon. And then, addition to this, HERMES adds some measurement capabilities to this constellation in cislunar space that really help complete the picture. So here is a sort of
2 minutes
cartoonish.
left, Bill.
So 2 minutes, did you say?
Yep.
Okay,
Yep.
very, very good. So here's a sort of cartoonish illustration of the configuration in lunar orbit with the 2 Artemis spacecraft. So it gives us a nice triad to investigate structures, ranging from about 5 to 10 Earth radii. And that's a range of structures that has not really been examined in the interplanetary medium, the solar wind. So it's also, that kind of structure is implicated in production of SEPs, associated with structures propagating through the solar wind. So, for example, as a CME comes by, and while the moon is in the solar wind, we'll be able to examine that fine structure and try and understand better how the particles are accelerated in that situation. These are the 4 instruments. Merit is our energetic particle telescope. Nemesis wins award for best acronym. It's a magnetometer system, but it's 3 magnetometers because they believe they'll need to use gradiometry to try and subtract the interference fields coming from the gateway itself. SPAN is a mass per charge ion analyzer, a mass spectrometer. That's a capability that we add here. Themis doesn't have that, so for unambiguous identification of, for example, atmospheric ions from the Earth, that will contribute. And EEA is an electron electrostatic analyzer, and it all fits into a package seen here on the Halo that is less than half a meter on a side, weighs less than 33 kilograms. Been a challenge in the development, but the project is miraculously getting there. Goal C, establish observational capabilities for this package. So let me just tell you, these are some of the things we think are going to be challenges to the data analysis. And one is potential magnetization of elements near the Hermes by the ion drive. The ion drive will not operate while we're in lunar orbit, except very
About 30
briefly.
seconds left.
3 seconds, okay.
30 seconds.
Oh, 30 seconds. Okay. Electric currents, of course, are going to affect the magnetometer. Spacecraft charging is going to be unusual. We already have some predictions of that. Limited coverage of the sky. Similar to that, we have some obstructions that we have to deal with, and then charged particle scattering. Although the Hermes objectives are heliophysics, we think that this can contribute quite a bit to studies of the moon. We'll see flux of terrestrial ions through the lunar surface, additional information on wake structure. Lunar proton albedo is within our capabilities, and lunar pickup ions. We will follow NASA policy. We will be entirely open with this data set and get it out to the public just as quickly as we can through our Science Data Center. Likewise, all of our software will be entirely open source. And in terms of current NASA science strategy, see ourselves certainly as enabled by the Artemis Gateway program, but also we think enabling of future exploration. So that's it. I'm probably 30 seconds over, but thank you for your attention all.
Yeah, thank you, Bill. This is a great opportunity, I think, for the heliophysics community, and a great show of how space weather and heliophysics is going to both enable and be enabled by, as you put it in that final bullet point, by Artemis and the Gateway. And so I look forward to seeing what comes out of the group.